recording, so we have this so I can post it for you guys. So this is for Nursing 130. The someone asked if this is the same as the earlier. It can be. It kind of really is up to you guys. If you have specific questions, we can certainly just dive right into those specific questions. If you don't have specific questions, then I can go over a couple of things, like the things that I know you're going to need to know review wise, things that you haven't seen yet, particularly like the flow rate type questions, because I know you haven't seen those yet because you didn't have them in 110. So, but if you feel otherwise okay with all that, we can certainly not do that and just do whatever. But if you do have a question, you can just type it in the chat or you can unmute. Just give me a second while I get some things closed here. Something. Someone said 25 ABC. I don't think you have an ABC on here. So if you're asking about the heparin protocol, we will do that in the 220, 230 review. So at 5 o'clock is when I do the 220, 230 review. This is the 130 review. Now, I will say this, if I don't have any additional questions and we finish up early with the 130 review, then I will certainly go ahead and jump on and do the heparin protocol, not a problem. Okay, so I just a couple of things just that I mentioned in the first session. And the good thing about recording these things is sometimes if I forget something, I've recorded it and I already said it. And if you go back and rewatch or review those, and these will be posted on YouTube, then you can see where if I said something or covered something a little bit differently or said something a little bit differently, then maybe that'll be helpful. So something to keep in mind when you're doing basic unit conversions, like 75 milligrams to grams, that answer is 0.75 grams. You do not round that to 0.8. You don't round that to 1. When you're doing basic inter-unit within the metric system unit conversions, you do not round those numbers. You will round, though, when you do something like going from pounds to kilograms. So for a patient that weighs 131 pounds, if I want to calculate their kilograms, I'm going to take the 131. I'm going to divide by 2.2, and I'm going to get 59.54545454. You're going to round that answer to the nearest tenth, 59.5. Does anyone need to see or have explained the urine output and then replacement volume question? Not, I'll skip it. All right, then let's go ahead into the things where I think you'll have the most challenge with, and that is the flow rate questions. Okay. So on the last few questions here about flow rate, there's a couple things you need to know. I'm going to pull up my screen here. Things you need to know about flow rate. the first thing you need to know is what in the world that means. So flow rate just means I have a volume over time. Really what that means is milliliters per hour. That's your flow rate. Sometimes you can have a flow rate that is indicated as drops, that's GTT per minute. The flow rate is either milliliters per hour or drops per minute. Other flow rates you might see later on will be things like units per hour. That would be another example of a type of flow rate. When we're talking about volume and time, the two pieces of information you need, sorry, the camera's adjusting to my hand there. The two pieces of information you need is the volume, usually in milliliters, and the time, usually in hours. If it's in minutes, you need to convert it to hours. If we're in hours and we're going to minutes, you just need to convert hours to minutes. So I'm going to start off with just an example. And this might actually be in the practice test, but this would just be an example. Let's say I have an infusion running. There's 375 milliliters of a particular IV, and it's running over 3 hours. And I want to know what to set the infusion pump to in milliliters per hour. And so all I'm going to do is I'm going to take my 375 milliliters volume over the time, 3 hours, and I'm going to reduce that. So 375 divided by 3, 125 milliliters per hour. Notice that there's no available, there's no ordered over have. It's just the volume and the time, and then reducing it to its simplest form. Okay, so that's the most probably straightforward approach when we're talking about flow rate. Now, where things get a little bit challenging are when we have like this, where we have the drop factor stuff. So in order to calculate drop rate, we need two pieces of information. We need the flow rate and we need the drop rate. So in order to calculate the drop rate, I need to know flow rate. I need to know drop factor. Flow rate is typically milliliters per hour. Drop factor is typically drops per milliliter. So you're seeing the drops is GTT. I know that looks like an H, but it's GTT. So in this question number 16 in your packet, it says the tubing package is labeled as shown below. When I look at the tubing package, I can see there's a big number 15 in the corner. So that tells me the drop factor, 15 drops per milliliter. It tells me that you're ordered to administer dextrose 5% water IV solution at a rate of 75 milliliters in 25 minutes. Now, and then it says, what is the flow rate in drops per minute? If it asks you the flow rate in drops per minute and you're looking for per minute, please don't convert this to hours, because then you just have to convert it right back to minutes. So don't do that. To answer this question, all you got to do is multiply by 15. Multiply the flow rate by 15, and you'll get 45 drops per minute. That is how you would calculate flow rate. All right. I'm going to follow the same strategy for pretty much all of these. Like this one down here, the 1440 cc's, that's my volume. 12 hours is my time. And then it gives me a tubing of 10 drops per milliliter. And what I want to do is then take my flow rate, which is the 1440 over 12, times the drop factor, which is 10. Now, as a shortcut, you don't want to, or because you know you're going into drops per minute, it's probably better that you go ahead and convert hours to minutes from the get-go. So 12 hours times 60 minutes is 720 minutes. So the way that I would set this question up is I would take my volume, the 1440, and I would put it over the 720 minutes. It's one less step to do. I mean, you did the step just kind of like as a prep step, but it's one less thing you have to like kind of put into your equation if you're following and doing an equation. So this is my flow rate. This is milliliters or cc's. This is minutes. And then I'm just going to multiply by the drop factor, 10. When I do that, I'll get an answer of 20 drops per minute. So again, all I did was I converted 12 hours to 720 minutes and then multiply. And then I did that because I know that I'm looking for drops per minute. Alternatively, you could have just taken your 1440 over 12 times 1 over 60 times 10, and you would come up with the same answer. But do all that extra work. All right. I showed you the Ringer's lactate, 375 over 3. Or calculating how long it's going to take something to finish infusing. I will show you what that looks like. So this says we have 0.9% sodium chloride, 500 milliliters, IV at 125 milliliters per hour. How long will this infusion take? How many hours? How many minutes? So let's look at that. So there's a couple ways you can do this. First way is the mathematical way. We can just take the 500 milliliters, infusing at 125 milliliters per hour. 500 divided by 125 would be 4 hours. Another way you can do this is you can say, okay, 125 milliliters, 1 hour, 250 milliliters, 2 hours, 375 milliliters, 3 hours, 500 milliliters, 4 hours. So you can kind of step up and get to your answer that way. You could also do 500 divided by 125 times the hour. That would work as well. If that's how you like to set up the question, it's pretty much saying the same thing. The question 17 about the NUR tube feeding. The other thing to keep in mind when you're doing flow rates is you might have to convert your minutes to hours, or sometimes convert hours to minutes. Sometimes it makes sense the way it is. Sometimes you need to do a little bit of converting. And so this one says that they're to receive 120 milliliters in 90 minutes. And then they want to know what would the flow rate be for that? What would be milliliters per hour? So there's 2 ways to do this. You can convert minutes to hours. So you know that in 1 hour there is 60 minutes. You do that conversion. 120 times 60 divided by 90 will give you 80 mil per hour. Alternatively, if you know that 90 minutes is the same as 1.5 hours, you can also just say 120 milliliters, 1.5 hour, and you can still get an answer from that for that. 120 divided by 1.5, and we're gonna get the same answer. So there's more than one way to come up with the right answer. Just if if you're doing these and you're just not sure if your way is you're getting the right answer, then you are likely doing it right. You just might be doing it a little bit differently than I am, which is perfectly fine as long as you're getting the right answer every time you do it. If you get the right answer, 2 out of 4 times, then you might want to check your strategy, because you might be flipping something every now and then that you shouldn't be flipping, meaning like a number or a variable or something. And then let me go into, because I don't think you've seen these yet. All right, so on the last page, like 21, it's going to ask you these are kind of like reconstitution questions. If we were doing, if you're at another campus, these questions are a little bit different, but what you're basically going to be doing here is it tells you the order, 60 milligrams. And then it says that there are 3 potential concentrations after reconstitution. There's a 5 milligram per milliliter choice. There's a 10 milligram per milliliter choice, and there's a 20 milligram per milliliter choice. And then it says, determine the volume in milliliters for the strongest concentration. So you need to know, what does that mean? Well, strongest means the most of the medication per unit of volume. So that would be, in this instance, that would be 20. So 5 would be the least, 10 would be in between, and 20 would be the strongest concentration. So to solve this, you would just take 60 divided by 20, and you would get 3 milliliters as your answer for 21. For 22, there's some extra information that you do not need to know. When you are looking at a label, and I'll pull up an example of a label in just a second, it'll say some things like you're going to add sterile water or an approved diluent to the powder that's in the solution. This usually happens within the pharmacy. This does not factor in to your math. This is just telling you what was on the label, and I'll show you what that looks like in just a second. And so what I do care about is, what are my concentrations? Units per milliliter. So I have 250,000 units per milliliter, 500,000 units per milliliter, and then 1 million units per milliliter. So which one is the strongest? The strongest is the 1 million units, because there's more units per milliliter. So I would take my order, 750,000 units, divide by 1 million units, and I'm going to get an answer of 0.75 milliliters. 0.75 milliliters. I'm not going to round that to 0.8. I'm not going to round that to 1. And the reason I'm not going to round that is because a number less than 1 is going to be rounded to the nearest 100th place. A number greater than 1 would be rounded to the nearest 10th. The exceptions to those rounding rules, as I mentioned earlier, is when you're doing those basic unit conversions, you do not round those basic unit conversions. Okay. And you'll see that when you're doing the practice test and you see the answers and you're like, oh, what is this? or I thought, why did they round this or did they not round this? And if you have a question about that, just you can email me or you can ask me. I'll be getting together with you guys, or at least for your section, the 1:30 section, on Thursday as well, same times, noon, and then 3:45 or 4 o'clock if I run over on my other section. All right. I want to show you real quick something here that I showed the earlier class. So let me just, and I put pictures of these drug labels just so you can kind of see what I was talking about with the medications. So I have the Pfizer pen that I'll show you. All right, so this is the Pfizer pen. This is what the label looks like. It tells you 1 million units, but it doesn't really tell you how to get your concentrations until you look over here. And so what we would have to do is rotate this if I can. Rotate it. So and I'm just going to kind of look on the side of my computer. It says the average single IM injection is 200,000 to 400,000 units IV. Additional information about the use of this product IV can be found, blah, blah, blah. Then it tells you the milliliters of diluent added, 20, 10, 4, 1.8. And then it tells you the units per milliliter solution, 50, 100,000, 250,000, 500,000. So the question is, like, how do you decipher like what you're going to use? And some of it might just be based off of what you have available or what you're told. So if I'm told to use the strongest concentration, I'm going to use the 500,000 units per milliliter. I don't really care about these here. These just tell me how much water was added to get to that concentration. What you care about is the concentration. I hope that makes sense. All right. For this question, I think you guys should be fine with this. All you're going to do is take the Visceral 60 milligrams, divide it by 50, get those milliliters. Then you're going to take the Mepridine 85 milligrams, divided by 75 milligrams, get those milliliters, add those two numbers up, round to the nearest 10th, and that is your answer for 23. 24 is a two-step weight-based type question. You're going to take the patient's weight in pounds, 176. You're going to divide it by 2.2, which I believe will give you 80 kilograms. 80 kilograms, then you're just going to multiply by 15, and that'll give you the amount for the loading dose. And then lastly, I'll work through number 25. Oh, sure. So someone's asking to go through 24. Yeah, if you need me to show it again, just let me know. Some of these things I'm skipping over just because I know that you can do them. And then if you have a problem with it, you can ask me about it. That's why I'm just kind of highlighting some things as opposed to, and then this is all being recorded, so you can always go back to it. But yes, we can do 24. 24 is a good like prequel, since sometimes when you guys next semester, when you do like your heparin questions, they're going to be weight based. When you get in the third semester, you're going to be doing pediatrics, which are weight based calculations. And so it'll be good to see that. So for number 24, we have a patient that weighs 176 pounds. So step one is we got to convert pounds to kilograms. So you do that by dividing by 2.2. and that gives you 80 kilograms. And it tells you have a loading dose of 15 milligrams per kilogram. $80 times 15 is 1,200 milligrams. So that's how you would calculate the loading dose for dilantin for question 24. Now for question 25, there's a little bit of a workup for that. So 25 says that the physician prescribes 500 micrograms of entecavir per day via NG tube. So let me just the physician prescribes 500 micrograms of entecavir per day via NG for a patient with chronic hepatitis B virus infection. The oral solution contains 0.05 milligrams per milliliter. So there's your concentration. And then it says how many milliliters of the antiviral will you administer? So I'm going to just write down some of the important stuff. 500 micrograms is your order. Your available is the 0.05 milligrams per milliliter. Now, with this, I have two different units. I have micrograms and I have milligrams. I need to convert one or the other so that they're the same units. We can't really do math efficiently, or at least science-based math efficiently, if these are not the same. So let's start off by taking my 500 micrograms and converting that to milligrams. If you just said 0.5 milligrams, you got it. If you're not there yet and you're not doing it that quickly, remember you can move your decimal over 3 to the left and get the same answer, 0.5, or we can use dimensional analysis. We know that in 1 milligram, there's 1,000 micrograms. And I just do 500 divided by 1,000, and I'll get the same answer, 0.5 milligrams. Okay. Now that I have milligrams, my availables in milligrams, now I can just divide by my available times the 1 milliliter, and then I will get 10 milliliters. Take a moment, look over some of the other questions. If there's something that you want to see again, or if you want to, if you have a question about one of the things or something I didn't cover, just either type it in the chat or unmute. Just tell me what you want to see. If you're good, then you don't have to stick around. It's completely up to you. You're welcome. Number 18. You have 500 milliliters that's infusing at 125 milliliters per hour. So I told there's a couple ways you can do this. You can just say, okay, 125 milliliters per hour. So in 2 hours, 250 milliliters. In 3 hours, 375 milliliters. In 4 hours, 500 milliliters. So that would be one way to solve that question. Or what I recommend is you take your starting IV, your total IV volume, divide by the 125, and that'll tell you how many hours it will take to infuse. Another variation of this type of question is it might tell you a start time and to calculate, the end time. So let's say I had let's just say I had a 1 liter solution IV that's infusing at 250 milliliters per hour. And it starts at, let's just say, noon. And I want to know, when will it end? So in order to solve this, is a couple of different ways. You could just look at that 250 milliliters per hour and say, okay, well, in 1 hour, it's 250 milliliters. In 2 hours, that would be 500 milliliters. 3 hours would be 350 milliliters. Sorry, no, 750 milliliters. And then in 4 hours, it would be 1,000 milliliters, which is the same thing as 1 liter. So this scenario would also take 4 hours. So if it started at noon, then you would know it would end at 4 p.m. because it took 4 hours. Now, if you don't like that process, you can then just take did previously, take the volume, the 1,000 milliliters, multiply it by the infusion rate. But remember, you're trying to get rid of milliliters and you're trying to be left with hours. So 1,000 milliliters divided by 250 milliliters will still give you 4 hours. And then you would just say, okay, it'll start at noon and it'll end at 4. All right, any other questions? All right. But if you have any other questions, like I said, I'll be here again on Thursday, same time. So we'll do noon. Yeah, you guys are 1:30. So we'll do noon, and then at 3:45, unless I state otherwise, on Thursday. If you have any other questions, please, you can also email me, and I'll try and get back to you and answer your questions as far as that. And then keep in mind that I have the YouTube channel that you can look at, and then I will post these recordings on there and you can review them, and hopefully that'll help you out there. So, and if I don't see you, good luck on your test next week. But like I said, you can reach out to me if you have any questions.